This project will look at a recommendation system which recommends courses. So basically a type of an Udemy course recommendation system. So as the tagline suggests, recommend similar courses for whichever the user is searching or looking for. Let's look into the workflow of this. We'll import the data from the dataset, we'll perform EDA and generate insights, and then we'll convert the text to numeric values and get some cosine similarity score. And based on the cosine similarity score, we can recommend similar things which are having similar score. So after finding the similar score, we will sort the values which have similarity score and recommend the course, and then integrate the recommendation system with the Flask server and deploy the whole application on Heroku. So this application is blend of many technologies which can be used, but in this we are just looking at natural language processing and machine learning and JavaScript for making interactive dashboards. Okay, so I'll just show you the demo of this. The demo goes something like this. So for example, if I have let's say that I enter the course how to maximize your profits trading options. This course, if I just give it and when I hit recommend, it is recommending me trading options basics, and one can also select on this and go to the course itself and learn. Okay, so from here also we can see that it is doing, and it is showing me the entire course on Udemy. So let's say that if I write Python over here and use recommend, so it will recommend me courses for Python. Recommendation for course Python are shown below. Learn Python and Django, learn coding for learn Python and Django and all. There are many, but to a limit I just kept it as a 6, because so that the UI looks clean and neat. So the UI is very basic here. It's no big thing in the UI, just a simple recommendation from end to end, right? So let us look at the dashboard part of this also. So dashboard will give you all the analytics of the Udemy, whatever is the Udemy data set, and how much profit is Udemy earning, and how many courses level wise are all people enrolling and everything. So EDA part is entirely based on JavaScript. This is purely done on JavaScript. The data is being transferred from Flask server to JavaScript JSON objects and then has been rendered on these charts. So we'll look at this part also, and we'll look at the home part where we can just give in some options, and then when I hit recommend, it will recommend me the following courses, and one can also browse through the course and can look at the course enrollment on Udemy website itself. So this is all about the introduction part of this very simple recommendation system which recommends courses. In the next video, we'll look at the exploratory data analysis and how we'll directly start off with plotting. We'll directly start off with recommendation system, and then in the later phases, we'll look at the exploratory data analysis of this. Thank you. Hi. So in the last video, we discussed about the overview of the entire course recommendation system. Now we will step by step build in the recommendation engine. The main recommendation engine will build, and after that we'll integrate that recommendation engine with the Flask server directly, and then in the later phases we'll look at the exploratory data analysis, because that is going to be done with JavaScript. Okay, so first things first, we'll import all the dependencies. Pandas for panel data or panel processing, NumPy for numerical processing, neat text.functions. This is a pretty good library which is used in natural language processing, which helps us to remove stop words, which helps us to remove special characters, which helps us in stemming, lemmatizing, and many more things in NLP. So we'll import neat text.functions and as NFX, and then from feature extraction Scikit-learn we'll import tf-diff vectorizer and count vectorizer. We all know the functionalities of vectorizers. They just convert they just try to get the scores on various categorical variables on basis of some mathematical formulas which are working behind the scenes. And then we'll import this metrics, we'll import this pairwise. From this pairwise module we'll import cosine similarity. This is the most important part in a recommendation system, the cosine similarity, which says cos theta equals to a vector dot b vector by norm of a vector norm of b vector. we all have studied this cos theta formula in vectors, in planes, in 3D dimensions and all. So the same thing is applied over here. Whichever things are having same kind of similarity, we'll kind of recommend them. That is the main crux of this recommendation system. Okay, so I'll just import it, and the data is Udemy course data.csv. So let's import it and let's see the data. So basically what we all need in recommendation system is we do not require any course ID, is paid, price, number of subscribers, anything. We are just bothered with course title, which is a text. We will process the text, we will analyze the text, we will make vectors of the text, and then we will create a similarity matrix of the text, and then normal sorting and searching has been done on it, and then we get the final resulted recommended system course. That is all to it, nothing more than that. Fine. So what we have to do, as we can see, we will be mainly focusing on course title. So the first things first, whenever there is some kind of text, we have to remove stop words from the text, we have to remove special characters from the text. So directly NFX module has these functions known as remove stop words and remove special characters. So we'll directly use nfx.stopwords, nfx.special-characters, one-liner Python code, one-liner Python data frame code. So df clean title is equals to df course title. So we are creating a new variable known as clean title. So that is equals to course title dot apply nfx dot remove stop words. We are removing stop words from the text, and then we'll remove special characters from the text as well. So once we execute this code, we will be getting a new column which is known as clean title over here at the end, which is the clean title over here. So this thing will have completely no stop words and no punctuation marks or special characters in it. So once that is done, we'll vectorize the clean title. So basically directly we'll start off with vectorization. No need of stemming and anything, because titles usually don't be big, so there's nothing to it. So we'll directly do the vectorization of the clean title. So count vect is equals to count vectorizer, which we imported from Scikit-learn a feature extraction text, and then we'll fit transform the clean title, and then we'll execute this. So we see that there is a sparse matrix of 3683 into 3654. So there are 3654 new features which has been generated by this count vectorizer thing, and then directly we'll go and find out the cosine similarity of this count vectorization matrix. So if I just look at, we get the cosine similarity matrix. So this cosine similarity is a numpy array. So if we just look at the shape of the cosine similarity, cossim.shape, if we just look at the shape of this, we will be getting 3683 into 3683. So we will be getting the same rows and columns cosine similarity matrix, right? Once we get the cosine similarity matrix, we will move ahead for recommending the course. It's so simple. In just 5 to 6 lines of code, we are almost there. Okay, it all became possible because of this neat text library. Basically, if we want to remove stop words or remove special characters, we used to use regular expressions and do everything. But everything has become simple in Python by creating a lot of packages by some very good people. So those people have created very good packages like neat text, and there are many more regular expression packages which remove all the special characters and whatever we want. The hugging face transformer is there, which helps us in stemming, lemmatizing, and so many things. So there are many various packages which helps us do all this. So in our case, our hero was neat text. So because of the neat text, our code became just almost 20 to 30 lines of code. That's it. So then after cosine similarity, let's say that we'll first drop, first we'll look at the course title and we'll drop if there are any duplicates in it. Okay. So first what I'll do is, let me comment this out first. So let me just see course index, how the course index looks like. Fine. So by default, I have given some title known as how to maximize your profit trading options from this. How to maximize your profit trading options I just considered. I copied, I pasted over here. So this is how the course index, this is how the series data frame looks like. Now if I want to look at the course index of title, if I want to get the title, or if I want to get the index of the title, what is the title over here? How to maximize profit, how to maximize your profits trading options. So if I want to get the index of this, how will I do it? I'll do course index of title. So that is what I'll get the index. So once I get the index, what I will do, I will find the in the similarity matrix, that is cost sim, I will find the where it is located in the cosine similarity. So in the cosine similarity I get this matrix, but what is this matrix? I'm not understanding anything. So what I'll do, I'll enumerate it. So what is enumeration is basically, suppose if you are having a list, okay, let's say that you are having a is equals to 1 comma 2 comma 3 comma 4. Now if you do list of, if you do enumerate of list, enumerate of a, if you do this, you will get an enumerate object. But if you do a dict or a list of them, you'll find something similar. So what is happening is, at 0th index the value is 1, at first index the value is 2, at second index the value is 3, at third index the value is 4. So basically we are doing this in case of enumerate. Okay, so cost of index is nothing but a list only. This is nothing but a numpy array or a list. Okay, so we will enumerate on this. So what if I do enumerate on this? What if I do enumerate on this? Okay, so if I enumerate on this, I'll get this enumerate object. Now I want to create that enumerate object into a list. So if I create like this, if you see, I'll get this at 0th index the cosine similarity score is 0, at first index the score is 0, second index score is 0, fourth index score is 1, fifth index score is some 20%, sixth index 20%. Like that I'll get so many, like for 3000 rows I'll get the indexes, index and the score, index and the score. Okay, so that is all about this list of enumerate of sim index. So what I did basically, I did a enumeration on the cosine similarity matrix. Okay, so if I look at the scores, what will I see in the scores? I'll see the index number and the score, right? So now what I need the course index, I need the sorted scores. So how will I sort? I will sort on basis of the values. Okay, so how will I sort it? It's very simple. So I will just write sorted of scores. Okay, I'll just copy this, I'll just paste it over here, and if you see, you can see that the score has been sorted based on the value, the second index. So basically lambda x axis to 1 is nothing but I want to sort the scores on based of the first index in the tuple. That is the meaning. So after sorting it, what I need the index and I need the score. So separately I will find out the index and separately I will find out the scores. So for that reason I am using these two lines. Okay, for that reason I am using these two lines. So that two lines just mean that selected course index is nothing but I of 0 for I in sorted scores. So for I in sorted scores, get me I of 0. So 4, 410, 43, 96, 138, all the indices will come. And I of score, basically I of 1 means the score over here, 1, 0.57, 0.56, 0.53 and so on will be stored in this selected score. So if I just execute this, it will execute successfully, and if I just want to look at the selected scores index, I will get all the indices which I just discussed above, like 4, yeah, basically after 1 I'm skipping the first one because the first one is the title itself. So yeah, the similarity score for title itself is the title itself. So what is the need of recommending that same course? We want to recommend similar courses to it, so we will remove it. So for basically it is 1.0, so we'll remove that. Okay, so that is the reason why we are using 1 colon. So we will skip the first one, from the second or from the first index we will start. So index, you can see it is starting from 410, 43, 96, 410, 93, 96 and all. So this is selected course index. Now what I want to locate all those courses, right? So how will I locate? Using the ilocate function, right? I am having the index. Now I am having the list of index. I am having the data frame. Why will I, how can I locate it? I can locate it with the help of iloc function. So with the help of iloc function, I will locate all the similar recommended courses, as you can see over here, right? Selected course index, and I have recommended them. Now what is the thing? Rec def of similarity score is equals to selected course score. Now I will place the selected score into a new feature known as similarity score. After getting all that, I will finally choose the title, similarity score, URL, price and number of subscribers which I want, and then I will display the recommended course. Now if I shift enter this, I will get the similarity score. I will get 3682 rows. Basically, similarity score, if I want to get all the similarity scores which are more than 50 or which are more than 5 or more, which are more than 0.5, basically what I can do is final recommended courses. Basically what I can do, final recommended courses of similarity score. If it is greater than 0.5, then only you show me. So how many courses are there? You can see that there are only some 1 2 3 4 5 6 7 courses are only there. And you can see the keywords also: trading, index option, heart options, everything, right? So basically whichever course is having similarity score more than 50 or 0.5, I want to recommend that. So you can use this. So this metric depends from company to company. How many courses do you want, how much metric do you want, and all, right? So this was all about the recommendation engine. So now in the next video we'll try to integrate this by dividing everything into small chunks which are nothing but functions, and our recommendation engine will be done. That is it to this. Hi. So in the last video we discussed about our recommendation engine, and we said that we would and I said that I would integrate this with the Flask server. So let's get started. It's very simple to do it, basically, because we have already defined all the functions. Basically we just have to copy them and paste them under a simple function. That is it, nothing more than that. Great. So how to start off? So don't look at the above thing, it will be a little bit complicated. Just come here, and over here first we will try to install all our dependencies or import all our dependencies. So from Flask, import Flask, request render template, pandas, numpy, need text. These are basically imported from where? You guessed it right, from here. These are imported from here, right? And the from dashboard we'll discuss about this, because this is all about the EDA part. So for now you can ignore this one, but these all are just imported from the previous Jupyter notebook. Okay, so let's get down to this hello world function. So basically we are creating a route at the starting point or the starting end point. Over here, if we just look at this, we are creating a route over here. This is nothing but the home page route. Okay, home page route. So what the home page is saying, so if request.data is post, then mydict is equals to request.form. Okay, mydict is equals to request.form. Basically what this is, basically this is nothing but a form over here, right? So when someone hits on recommend, so the data, as this is a post request, so post request carries data along with it in the form of a request. So we have to extract the thing which the user has said, right? So that we will store it in mydict, and in mydict specifically we want the title, so that is why the title name we get it from mydict, of course. So once this is done, now what we have to do is we will run a try and except block over here. This is very important now. Not all the courses which will be having some similarity. There will be few courses which we have to define which do not give some kind of similarity. So we have to tackle all those also, all those edge cases also. So first edge case the first case is if the course is having some kind of similarity score or some similar courses are there, then directly use this cosine similarity logic and show it off. But if there are some courses, so for example, if I look over here, if I just type in machine learning, so there are no courses for machine learning. So we have to give over here that seems like there are no similar courses for machine learning. We'll say the course administrator for uploading a course. So if we see trading option basic, if I say trading option basic, then there are no courses available for it as well. But if I say Python, then there are no courses were available for Python as well. But as Python was a keyword within the title, we can recommend that as well. So that is how we have to architect our recommendation engine. So first priority is to give for the cosine similarity. If there is no kind of similarity between that, just try to find out where the particular keyword, in which keyword is that particular keyword present in any of the titles or not. If it is present, then display it, else do not. Else we can say that the course administrator will update the new courses soon. Okay, so in that way we can adjust our try and except logic. So in the try, we will read the data. So these functions are basically the read data function, that if we go and see the read data function, it will read the data from the data file pd.read csv udemy clean title and return df. So once that is returned, we will go and check for the clean title. So clean title is where is the clean title? Over here, df of clean title is equals to df of course. So from where did we get this? So from here we got it, right? So first the second cell only we copied and we kept it in the clean title place. Great. After that, what we have? Get cosine similarity matrix. So where is the cosine similarity matrix? The cosine similarity matrix, get cosine similarity matrix, it's over here. So what is this cosine similarity doing? It is just basically converting the count vectorization part. So just copy this, paste it over here and return the CV mat. So once the cosine similarity matrix has been returned, sorry, this is the count vectorization matrix. Okay, so once the count vectorized matrix has been written in this, now what we have to do, we'll say that our number of recommendations are 6. In a web page we can recommend 6 courses. So over here there are 6 courses, right? Maximum we can recommend 6 courses. That is the meaning of it. Okay, cosine matrix is equals to cosine mat of CV mat. So this CV mat is basically a count vectorization matrix which we saw over here. Count vectorization matrix is a sparse matrix which we saw. Now we want the cosine similarity matrix of it. So how we can get, we have this function named as cosine sim mat. So where is this cosine sim mat? Over here. What it is returning? Cosine similarity of CV mat. What is the CV mat? This is the count vectorization mat. From where did we get the count vectorization mat? From the cosine similarity mat function. Okay, so we will return the cosine similarity of CV mat. So we will get the, so what we will get? We will get the cosine matrix. Now after all these, now we are passing the main function, that is data frame. We'll pass the data frame, we'll pass the title name which we are getting from the user. That means the user will type it over here, and that is the title, and then the cosine mat which we just calculated over here, and then the number of records which is this parameter. Fine. So this all is been done. So this function recommend course will go to this recommend course function, which takes in data frame, title which has been passed by the user, and the cosine matrix or the cosine similarity matrix, and the number of records which we want to see. So the entire code over here is present over here. We discussed that in detail over here, right? So just what we need to do is simply copy this and paste it over here. Simply copying and pasting over here. That's it. So what is this function doing? This function is sending us the recommendation, top recommended courses for which are similar to the top recommended courses which are similar to the course which the user wants. Okay, so that will store it in this recdef. Now from that recommendation data frame, what we need to extract? We need to extract URL of the course, URL of the course, the title of the course, and the price of the course. So we have defined some separate function known as extract features. So this extract features will return me the URL of the course, title of the course, price of the particular course. So course URL, course price, course title, everything will be returned. So that everything I have. Now what I need to do is I will form a dictionary of course URL and course title. So course title and course URL, if I want to make 2 lists into a dictionary, I will use this dict zip function. So this course title and course URL are the features from which I extracted using this extract features, which are nothing but lists. Course URL and course title are lists. I want to zip those lists and I want to create a dictionary of it, right? So now I am checking if my dictionary length is not equals to 0. If the dictionary length is not 0, then return render template index.html course map is equals to dict map, course name is equals to title name, show title is equals to true. Okay, so I will see in this index.html, if I go to the index.html and over here there is one for loop which I just wrote. Okay, so yeah, over here there is a for loop over here. So for course in course map, so for courses in course map, okay, so this course map is a dictionary which is consisting of course title and course URL. So what it is, so for course in course map, this is a card, and this is a card which is similar to this one. a card. How I get this card is basically go to bootstrap.com, go to bootstrap, and then over here just type in cards, and you can search for cards over here, or basically you can go to examples. You can see the cards over here as well. So this is the card which I took. So how to get that card? Simply inspect, go to this part, hover over here, you get the entire div class is equals to row, class call md4. You can copy this. So these are how many cards? 9 cards. So there are 9 divs over here accordingly. So you can select any one of them and just copy it. Just click on this, edit as HTML, Control C, Control V. That is it, nothing more than that. Okay, so that card I have just kept it over here, and over here I've just changed the name. So I've just kept course and then course map of course. So what is course and course map of course? So course is nothing but the title name. The course is nothing but the name of the course. That is nothing but course title. Okay, and course URL is nothing but course of course. Course map of course is nothing but URL. Okay, so what is the URL over here? You can see this is the URL. If I click on view course, it will just take me to the new tab. It will take me to the new tab. So that is all about the recommendation engine of this. Okay, so for courses and course maps, so from where this course map is coming? The course map is coming from here. Course map is equals to dict map, and what I am doing over here, I am writing a Jinja for loop over here. So in this for loop, it will continue, and then when the course map length becomes 0, it will end. So basically, if my course map is 6, if the length of the course map is 6, so 6 cards will be rendered in this way. If my course map is 5, then 5 cards will be rendered in that way. So that is the entire logic of this recommendation system. That is all to it. And yeah, so if the try is successfully executed, then the template will be rendered. That means if the length of the dict map is not equals to 0, then it will. If the length of the dict map is 0, that means there are no similar courses. Then what to do? Then I have defined a show error is equals to true. Course name is equals to title name, right? So once go over here, if there is one thing known as show error over here, right? So the show error will display the error template. That is nothing but seems like the course name which I am getting from this course name is equals to title name is not available. So for example, machine learning course was not available in our data set, right? So that is why this recommendation engine did not get it. So it's saying like seems like course for machine learning is not available. Currently we'll report to the course administrator for recommending the course. But if Python I keep, Python is coming, right? If I keep maximize your trading options courses are coming. So that is all about the try block. Now what is there in the except block is very important, right? So try block is done. Now except block is very important. So basically I defined a function known as search term, which will take in the parameters as title name and data frame. So if I go and look at the search, so I am selecting the course title which is containing that specific term. So that specific term is nothing but the title. So for example, over here I am writing Python, right? So Python, there are no courses for Python basically. In the dataset, if you look, there are no courses for Python. If you just type in Python over here, you will get nothing over here. For example, let me just show you. If df of course title cleaned, let me just take okay, course title, if I just keep double equals Python, if I keep, see, there are no courses for Python, but Python is a keyword in many courses. So that in that way we are recommending Python courses. Okay, so if I just hit on recommend, so this the Python is a keyword in the course, so that is why it is getting recommended. So that is nothing but this keyword recommendation over here. This except block is all about the keyword recommendation. Okay, so this search term, if I just look over here, it will select the term, whichever term is having the keyword, and if it is having, then sort by values, sort by the number of subscribers. How many subscribers are enrolling in that particular course? The course which has the maximum number of subscriptions will be shown, and it will be sorted in descending order. Then we'll return the top 6. So that will come over here in result df. Now they will see if shape of result df is greater than 0. If it is greater than 0, if it is greater than 6, then we will take the first 6 parts, and then again we will extract course URL, course title, course price of that features, and then again we'll do a map, and then we'll do the same kind of thing which we did in the try block over here. So this same kind of thing is copied. So this same kind of thing is copied and pasted over here. In else part, that means if the result df is equal to 6 or less than 6, then we will extract the same thing is copied and pasted over here. Okay, so this was all about the except part, and then this render template index.html is rendered as usual. So this was all about the recommendation engine of this. We covered all the extract features, search term, recommend course, cosine similarity matrix, read data, and get title. And now in the next video we'll look at the dashboard part, which is nothing but the integration of JavaScript. Thank you. Hi. So in the last video we looked at the app.py file, that is we build our recommendation system. So in this video we will build the exploratory data analysis part, that is nothing but this dashboard part. Okay, so we are having this dashboard right over here. We will be building this dashboard, right? So how we will go about building the dashboard we will see in this video. So here in order to make things well organized, I have defined another separate Python file named as dashboard.py, where I have defined all the exploratory data analysis functions. So all the function definitions and function description is written in the dashboard.py file, which is over here, as you can see, right? So now what I will be doing is I will be explaining you the dashboard.py, each and every function of the dashboard.py now. So the first thing is the slash dashboard is nothing but our route over here. We can see we have this route as slash dashboard, right? And the methods to that dashboard are get and post, and we define a function under this route that is nothing but dashboard. So we read the data because we want the data frame first. So we as I discussed the read data function in the previous video, which will read the data file, and then this get value counts function is defined in this dashboard.py file, which will basically return the value counts of the subjects. So basically if I copy this and if I see in the Jupyter notebook over here, I have this dict of df of subject of dot value counts. So if I execute this, I get the count of the subjects, which all subject domains have what all courses, right? So that is about the get value counts function. And get level count function is another thing which will give us the number of subscribers level wise. Now what do I mean by level is basically expert level, beginner level, all those kind of things. So this is the way how we can do it. So we'll group the number of subscribers level by, okay, so we'll group the number of subscribers level wise, and then we will count. So this basically will give us a dictionary, and then we will take the items of it, and then we will slice the part. Why we are slicing this is because of this. Okay, so if we just do, we are simply getting all levels and all, right? So this is all about the number, getting the number of subscribers level wise. Okay, then getting the level count level wise, right? Then we have our number of subjects per level. So this is little bit tricky over here, getting the number of subjects level wise. So first what we will do is we will break down this entire thing into small pieces. Okay, so the first small piece is this. So if I group all the subjects level wise and I see the value counts, so I get this. So subject is business finance, and levels are all levels, beginner level, intermediate level, expert level, and these are the counts of this. So basically what I need is, I need business finance underscore all levels, business finance underscore beginner level, business finance underscore intermediate level, business finance underscore expert level. So this business finance must be mapped to each and every one of this, and the counts are separate, right? So how will we do that? If we do this, and if we just type in dot keys over here, if we try to make it into a dictionary, and if we try to write it as dot keys, we will be getting the keys, okay, as shown over here. And if we convert it into a list, that will be displayed something like this over here. So this is nothing but the list of the keys. Now what I need is, I need to join these two. So for joining these two, this is the method how we can do it. So if I do this, I get all the keys at one place or in one word, right? Now I have the keys. Now I want the values. So instead of keys, I will just type in values, and I will execute it. Now I have all the values. Now I have all the keys. Now there are two lists. In order to make two lists into a dictionary, we can use this dict of zip of all libs ans values. If we do this, we'll get a dictionary. This is what we wanted, right? So this is the thing which this get subjects per level function will return, that is subjects per level. And the last thing is year-wise profit map subscribes year-wise profit function, which will return year-wise profit map, subscribers count map, profit month-wise and month-wise subscribers. So if I just copy the code from there, so over here we have profit year-wise and subscribers and everything, right? So if I just copy the entire code from here and here to here, I'll get the thing over here, right? So if I just execute this, so this is basically changing the publish date to a pandas datetime object over here with the year, month and date format, and then year is equals to publish date dot dt dot year, month is equals to publish date dot dt dot month, day is equals to publish date dot dt dot day, and so on. So if I look at the head of this, so I'll be getting all the year, month, day, month name, everything. Now what is the thing is, I need to know the profit map. So for knowing the profit year wise, what we will be doing is, so for knowing the profit year wise, so profit we will get it from this thing, okay? So we will do this, and if I look at df.head now, I will get the profit here, right? So yes, so basically if I need to get the profit year wise, so I will group the profit year wise and I will find the sum. That is what is written over here. Profit map is equals to dict of df dot group by. Similarly goes for subscribers map, okay? Similarly goes for subscribers map and the profit month wise also. So for month wise, as I have made this dot month function, right? As I have made this dot month thing, so that is carried over here, and I will get the profit month wise, I'll get the number of subscriber year wise, I'll get the number of subscribers month wise. So all these data frame, all these dictionaries will be transferred to the JavaScript file in form of objects. So this dashboard.py file will return all dictionaries which are over here, and we will pass all these dictionaries to the JavaScript file, and we will see how to make an interactive dashboard with chart.js in the next video. Till then, do practice on group by and pandas functions. Thank you. So in the last video we discussed about how the data is flowing from this dashboard.py file to the app.py file in form of dictionaries. So whatever these functions are returning, these functions are returning dictionaries, and the reason why they are returning dictionaries is JavaScript. In order to get the data into JavaScript, we need Python dictionaries, because JavaScript takes data in form of JSON objects, which are nothing but key value pairs. So in Python, key value pairs data structure is being represented with the help of dictionaries. So that was the reason why we formed dictionaries, right? So here we have these year wise profit map, subscribers count map, profit month wise subscriptions from this year wise profit, and then we are returning everything, we are rendering everything of each and everything which has been returned from here on this template. So what is this template? Dashboard.html. So let's look at the dashboard.html file. So here is the dashboard.html file. So this is the navigation bar, nav bar, which is present in almost which was present in the home page as well as recommendation page and the dashboard page. So over here we are defining some charts. So the charting library which we are using in this case is known as chart.js, right? So chart.js, a very simple open source HTML5 charting library which you can integrate in your JavaScript codes. Over here they have seen, say, canvas id is equals to my chart, height is equals to this, height is equals to this, width is equals to this, and everything of this thing is to be written in the script file. So in Python, in this, as we are using the Flask framework, so we have to mention some kind of block JavaScript over here. So inside this block JavaScript, write JavaScript, write the script tag, and then we can get the data into these values. So what is this is saying is var is equals to value counts of safe. So where did we get this value counts over here? We got this value counts from where are we getting the value counts? Basically we are getting the value counts over here. We are getting the value counts from this get value counts function. So value counts is equals to value counts of safe. So basically that is a Python dictionary, and we want to convert that Python dictionary into JavaScript object. So for that what we need to do is we need to mention this safe keyword. If we mention the safe keyword, the JavaScript engine will understand that, hey, that is a valid file or valid data structure, you can accept it as an object. So that is why you have to mention the safe keyword. That is very important. Okay, so whatever is been dumped from here, is been caught over here, right? Now these are also key value pairs only, so we need to separate keys and values. Why we need to separate keys and values? Because keys will represent this is the key. See, for example, graphic design is there and the count of the graphic design is 603. So graphic design is the key and value is 603. So we have to separate keys and values so that we can plot our data on the chart. Okay, so for that these all arrays are made over here, right? These all arrays are made in order to save the keys and values. So level count 2, subscriber count, profit count, subscriber count month, etc. Now we are running a for loop for const item in value counts, const domain name dot push item, domain name dot push value counts of item. So everything is very simple. What we are just doing is this domain name is adding the key and this count domain is adding nothing but the value, nothing more than that. So if you are having any kind of doubts, what you can do is you can just write console.log and you can give anything over here. For example, I'll give value counts. I'll save this and over here I'll open the console. Okay, over here I'll open the console. I'll refresh this. See, you can see this key value pair which is getting rendered, right? So this is what is this value counts. Got it? So I want to iterate through that object. So you can write how to iterate through an object in JavaScript in Google over here, and you can search for various methods. This is one of the method. Like I want to I will run a for in loop, that is const item in value counts, domain name dot push item, domain count domain dot push value counts of item. So this is one part. Similar to this, we are having this courses level, this thing. Similar to them, we are just simply doing all this simple for loops, and we are storing all the keys and values separately in the separate lists which we defined over here. So once we get our keys and values, we'll define our charts. So what is the chart over here? First chart is document.getElement by id of chart. Okay, document.getElement by id of chart. So this getElement by id is very important. So where is this chart id present? the chart ID is present over here. See, chart ID is present over here. ID is equals to chart. So where did we get this canvas from? We got this canvas from here. Got the idea? Canvas ID is equals to my chart. This is the thing. So instead of ID, instead of my chart, I kept it as chart. Right? So just that canvas, I kept it over here. This is nothing but the bootstrap thing. Inside that bootstrap, I'm writing this canvas. Got it? So that canvas I kept, and from where did I get all this code? Just simple. After the script tag, what is there? Const my chart. This everything I copied and I pasted over here. And whatever I want, I kept. Other things I removed. I wanted labels, I kept domain name. Label is equals to domain name. Data is count domain. I kept some background colors. Other things I just removed. That's it. And type is very important over here. So how to get the types? Various types of charts on chart.js. Go to chart types. You have line chart, bar chart, radar chart, donut chart, polar chart, bubble chart, scatter chart, area chart, mixed chart types. You have heap lot of resources on this. You just need to, what you need to do is you just need to click on this button, copy, and then just you have to paste it somewhere. You just need to paste somewhere. That's it. Nothing more than that in this. So this was the chart number 1. What was the chart number 1 over here? We are saying number of subscribers domain wise. I want number of subscribers level wise. So how to get the number of subscribers level wise? So number of subscribers level wise we want bole to we have this chart number 2 over here. So we have to get document.get element by ID level 2. If I go at the level 2, this is nothing but chart 2. So we'll come down. Yeah, so this is the chart 2, right? Yeah, so chart 2, and that is also donut type, and level name, level count, level name, level count. That's it. Background color. I just copied this and I just pasted here. Instead of labels and data, I just removed the labels which is there in this. I kept some other data over here. That's it. Similarly, all the charts are made. You can go and explore on these things, and it is very simple to use this chart.js library. You can explore on these donut chart, pie charts, and everything. So yeah, that was all from this JavaScript thing. The main important thing over here is the data, how the data is coming from Python file to this save keyword was very important, and also conversion of those Python dictionaries key value pairs into separate keys and values arrays in JavaScript is also important, which we can do it using this simple for in loops. That's it. In the next video we'll look at the deployment of this. Thank you. Hi. So in the last video we'll look at how the data on the JavaScript is getting rendered on the charts, and in this video we'll look at the deployment of the entire course recommendation system on Heroku Cloud. So for that we will require two important files rather. One is the proc file, which is this web gunicorn app.app. This proc file will say the Heroku server that hey, you have to start your rendering the service from this app.py file, and then there is this requirements.txt file which is containing all the requirements which we have to install. Okay, so what we will be doing over here is very simple. We will be creating an Heroku application. So what we will do is, if you are new to Heroku, so you can go to cloud.heroku.com, and then over here, if you are really new, then you can hit up sign up, and then you can fill in all the details, and you can get the data over there. You can fill in all your details, and you can get an email ID, email registration link on your registered email ID, and then you can click on OK, and then your account will be created on Heroku. Else, if you are already registered, then you simply hit on login, and then you just type in your email address and password, and you just type in login. So after you do all of that, the interface will look something like this. So now what we will do is we will create a new app, and then make sure that you give some unique name to this. So if I give some course recommendation if I give some course recommendation engine, let's say if I give this name, so yeah, course recommendation engine is available. If I say system, then it may not be available over here. Yeah, it is available. Okay, good. So course recommendation system, uh, then I'll hit then I will say create app. Okay, so once I create the app, now I'll be having three versions. Now I'll be having three options how do I deploy my app. So over here, one option is Heroku CLI command line interface, then it is GitHub, and then container registry. So I will be using command line interface because I'm used to command line interface, or you can also use GitHub. What you need to do is you just need to dump your code on GitHub, and then you have to connect your GitHub account over here. That's it. And then just keep on simply okay, and then automatically this will do it. But I rather prefer using command line interface. So if you do not have Heroku CLI, just go over here and download the Heroku CLI from here. If you don't have the Heroku CLI or Heroku command line interface, go to this link which they have mentioned over here, and you can download the Heroku CLI based on the your operating system. If it's Mac OS or if it's Windows or if it's Ubuntu, you can download it. And then once that is done, what we need to do is we need to check in our terminal over here. I will open my terminal. So first let me just change this to Python 3.8.2 so that there are no errors which are coming over here. And then I will open my terminal, and then first I will check whether Heroku CLI is correctly installed or not. So if I just type in Heroku, I should get a list of commands over here. So if I get a list of commands, that means Heroku CLI is correctly executed into my installed into my system. Now what I will do is I will copy the command step by step which they have mentioned over here. So I'll just copy this Heroku login. I'll copy, I'll paste it, and I'll hit enter. They will say they'll give some key value. I'll press some key value, accept Q, and then this will show me the deployment now. So yeah, I'll hit on login. So yeah, so once login is done, what will happen is I'll get this. I have logged in with this email ID, and so now what I need to do is I need to go to this dev center over here, and then I will copy. I will not copy this because I'm already in a project. So what I'll do is I'll create git repository over here. So if I just paste it, git init, if I do, you can see that this will now be created to a master branch over here, right? This will get created to a master branch. So now what I need to do is I will use this Heroku git remote course recommendation system, sorry for that, copy and paste, enter. So waiting for Heroku update from 7.4, and then this is created. This git container is created on Heroku server now. Now I have to add all my files, so I will use this git add function. So if I press that, it will add all the functions, right? So now I will do git commit, copy, paste, and last but not the least, git push Heroku master, the last step in the entire deployment. So if I just do git push Heroku master, the git repository which we created over here, which was this git repository which we created, it will now get pushed on the Heroku server. And this requirements.txt, everything the Heroku server will download or install all these packages which are mentioned over here, and that is it. It will download or install all the necessary packages and then things, and then we all have the packages installed on the Heroku server, and then it will send us the link within some time. Now as there were less packages, so it got installed quickly, but if you are having very big packages like TensorFlow or anything, then it will take a lot of time to do that. But over here the time taken is a little bit less, and I think I will be receiving the URL soon. So it is compressing all the files, putting it all together in the server, and now within 2 minutes I think I'll get the URL of my end project of course recommendation system. So it showed done. Now it is showing that this has been released on this. So this is the URL. So you can just click on this follow link. So this will, yep, this is entirely deployed. If I hit on recommend, so yes, this will take a little bit time because it is not yet completed, right? It has been launched but it has not yet been completed, so we have to wait. Yeah, so verifying done, deploy, verifying deploy done, git push Heroku master. This is the git repository which got pushed onto Heroku server, and we can see the end result over here, course recommendation system.herokuapp.com. Now if I hit recommend, so either the storage is overloaded, it seems. So let's go to dashboard once and check. Okay, so yeah, so this is all about the deployment phase on this Heroku. This is all about the deployment phase of this Heroku app. Basically, you can go and look at the maybe because there are a lot of requests which are handling on that, so that is why that is the thing. But this is the way how you can deploy your applications on Heroku Cloud. Thank you.